Hello everyone, a very good evening to all of you. First and foremost, if audio and video both are working fine, please let me know before we begin. Great, all good. Right, so let's begin with our session. Now, today there are two chapters that we are going to look at. One is defense, which is a very small chapter. And as I told you yesterday as well, that this is a chapter that is more important from your current affairs perspective than the static areas that we are going to discuss here. So that's the first chapter, and then second chapter that we'll start with is IT and communication. Now, IT and communication is a chapter which is fairly important from your prelims perspective, especially. So more about that when we get to that chapter. So first thing, when it comes to defense, let's try to understand some of the aspects of defense. And before we go on to understand the basics of defense, there is something that I want you to understand. Yeah. So so just understand about defense or how exactly you have to go. One of the most important I would say source for you is going to be the DRDO newsletter. DRDO newsletter. Now this one article that you see here, this article is something that I've taken from the DRDO newsletter of May 2024. This is, I mean, let me not write May 2024 here. So this DRDO newsletter, if you see, this is an edition that I've taken from the May edition. Now, this article. So why is this newsletter important? So this newsletter basically is a PDF document that on a monthly basis is published by DRDO on its website. If you go to DRDO website, if you go there, there is one segment called as publications, and if you go to publications, you will find DRDO newsletter as one of those publications. So just go there, you'll see that month wise you'll find all these newsletters. Now these newsletters, they basically are 20, 24 pages, 28 pages sometimes. uh, but out of all those pages, there are 2 or 3 pages in every at various offices of DRDO. So obviously all those things are not important at all. Only if you see couple of pages at the beginning is where they talk about all these new developments in the field of defense. So only go through that. All right, only go through that, and no need to go through anything else apart from that. Now, so that's why we see that this defense is something that has to be read from current affairs perspective. Now, coming to some of the basics of defense and something that needs to be understood well, one of the most important topics in defense is about missiles. And also, one of the areas where you'll see that a lot of focus will also be put upon by India. Now, when it comes to missiles, we know that it is a rocket propelled weapon which has been designed to deliver an explosive warhead with great accuracy at high speed. Now, they can either be used in offensive ways or in defensive ways. All right. So either it can be used for attacking somebody, or it could also be used to defend ourselves. So there are both these ways in which we can make the use of these missiles. Now, Typically, this is how you would look at a missile. Now that this is where you have the warhead. This is the warhead of the missile, correct? And this you can say is like the launcher. Just how we saw with regard to the satellites, similarly here also, the warhead becomes the payload, right? Just how their satellite was the payload, so here the warhead becomes the payload, and it is being carried by a launcher similar to a launch vehicle like PSLV or GSLV that we saw in space technology. So this is typically how any missile looks like. Now there are different ways in which we classify the missiles, and these classifications, they are important for your examinations. For example, what happens is that they give you the name of a missile, and we'll see an example question towards the end, something that was asked in your 2023 paper. So we'll discuss that question, where you'll see that information regarding a certain missile is many a times mixed up. So, for example, a missile that has a short range will be called as a long range missile. A missile that is a surface to surface missile will be called as a surface to air missile. So, these kind of mix ups are done by UPSC when they ask questions based on missiles, so that people might get confused in what the correct information might be. So that's why when you look at any missile, when you read about any missile that is in the news for one reason or the other, look at all these things, look at all these parameters. So classification of the missile, for example, on the basis of range. So on the basis of range, we have short range, intermediate range, long range, and intercontinental missiles. So short range missiles will be the ones which have to cover, like say, 50 kilometers, 100 kilometers, maybe 200, 300 kilometers, that's it. So these kind of missiles, they will be called as short range missiles. And then after that, you have intermediate range missiles. So intermediate range missiles are of the order of 1000, 2000 kilometers maximum. Although many a times intermediate is not even a word that is used. Many a times, instead of intermediate, it will either be called as a long range or a short range missile, depending on what kind of missile it is. So that information that you get while any flight testing of missile is happening, that becomes crucial. Then long range missiles will be the ones which have 2000, 3000, etc. Kilometers as the range. And ultimately you have the intercontinental missiles, which can travel from one continent to another, and that's why they are being called as intercontinental missiles. So for example, sitting in India, you can target Africa, Europe, US, or let's say Australia. So then in that case, these will be called as intercontinental missiles, and that's why they would have a very long range. They would have a range of 4000, 5000, 8000, 10,000, 12,000 kilometers, and so on. So that's why these will be very, very long range missiles or intercontinental missiles. So this is the first way in which we classify the missiles. The second way to classify the missiles is on the basis of start and end point. So whether they are starting, so surface to surface means that they are starting on the surface and they are ending also on the surface. So that's why they are surface to surface missiles. Similarly, surface to air, meaning that starting from surface going to air. So this is the start and this is the end. So this is how we classify the missiles. This is the second way to classify. Then the third way is on the basis of their path or their trajectory. So on that basis, we have ballistic and cruise missiles. Now, this is a very, very important classification. One of the most important ways to classify missiles is on the basis of what kind of path is the missile going to take. So on one hand, we have missiles which are called as ballistic missiles. And on the other hand, we have missiles which are called as cruise missiles. So let's also try to understand the difference between these two missiles. So if you look at this picture, this gives you a clear indication of what do we mean by ballistic versus what do we mean by a cruise missile. So a ballistic missile, as you can see, that it is starting and ending and has a parabolic path. It has a parabolic path. It's just like how if you had a ball in your hand or a stone in your hand, how would you throw it? So when you throw a ball, the kind of trajectory that the ball takes, that trajectory, that path is called as a parabola. So that's why this kind of a shape is called as parabola, and that's why this is called as a parabolic path. So these ballistic missiles, they would take a parabolic path. On the other hand, the cruise missiles are similar to an airplane, where you control the path. You control the path, right? That the flight will take the path in accordance with, however, we are controlling the path of this aircraft. So that happens in a cruise missile. That cruise missile will also take a path based on how are we maneuvering or controlling the path of this uh, missile. So that's why first thing, that it takes a parabolic path, and in case of cruise missile, it has a controlled path like airplanes. All right. So this is how we see the difference between ballistic and cruise missile. Then after that, the second way to classify, the second difference rather between ballistic and cruise missile is the speed. What we basically see is that ballistic missiles, they travel at higher speed, they have comparatively higher speed, whereas cruise missiles have lower speed. Cruise missiles have lower speed. So that's another difference. Then the third difference between the two is that ballistic missiles have higher carrying capacity, or let me say that they have higher destructive capacity. They have higher destructive capacity because they can carry more load, they can carry more warheads, they can carry more weapons. So that's why they have higher destructive capacity, and cruise missiles have lower destructive capacity. Then another difference between the two is on the basis of range. Ballistic missiles, they have higher range, and cruise missiles have lower range. Now on the basis of all this, you might feel that ballistic missiles are better missiles, correct? It seems like that, higher speed, higher destructive capacity, higher range. So looks like ballistic missiles are better missiles compared to cruise missiles. So why do we even have cruise missiles? What's the point of having a cruise missile? This is where you have to understand, where does cruise missile become better than ballistic missiles? And this is when you have to have a better accuracy. So in case of ballistic missiles, they have lower accuracy, they have lower accuracy, whereas in case of cruise missiles, they have higher accuracy. And very simple, why? Because you have a controlled path, right? You don't have a predetermined path. Ballistic missiles have a predetermined path that you have already logged onto the target and then you are launching. So there is very little chance that will be able to change that path. But in case of just like throwing a stone, as I told you, that the path that ballistic missile takes, the parabolic path is the same path as you throwing a stone or throwing a ball, correct? So once you have thrown the ball, you cannot change its course. It will take the course that whatever you have predefined. But in case of cruise missiles, it's like an airplane, so accuracy is higher because you can control the path, you can maneuver the flight path of this cruise missile. So that's why cruise missiles become more useful when you need higher accuracy. When you need higher destructive capacity or higher range, then longer range rather. Uh, so this is one mistake, sorry. Longer range and shorter range. longer range and shorter range. Yeah. So, pardon my English. So, yeah. So in this case, that's why when we need better accuracy, when we need higher accuracy, this is where we need cruise missiles. There is another difference, and let me also write that also. These are generally strategic missiles. We'll discuss about what strategic missiles are. Generally, these are strategic missiles, and generally we see that these are, we'll write generally. Generally, cruise missiles are tactical missiles. We'll just discuss in some time about what exactly do we mean by strategic and tactical missiles. So that's why these are the differences between ballistic and the cruise missiles. And to classify a missile, this is the most important parameter. All right, this is the most important parameter that we need to classify a certain missile. So this is how we look at ballistic versus cruise missiles. Now, there is another way to classify, and this is on the basis of utility. So on the basis of utility, we have strategic missiles, and then we use strategic missiles, and then we have tactical missiles. So let's try to also understand what do we mean by strategic and tactical missiles. So now strategic missiles, as we just discussed, that ballistic missiles generally are strategic missiles and cruise missiles are generally tactical missiles. So what do we mean by these two? So strategic missiles generally are missiles which have longer range, which have higher destructive capacity, which are nuclear capable most of the times. So that is basically what we see in case of strategic missiles. So that's why, for example, let's say any missile which is strategically important for us, we might not want to use it, but we want to have it. So for example, let's say any long range nuclear capable missile, we don't want to launch it, we don't want to use it, just that we want to be ready. We want to be ready that if at all it needs to be used, we should be in a position that we can use it. And many a times that's why we say that these strategic missiles, they also give us something called as the second strike capacity or second strike capability, right? So they give us second strike capability. So that's why we see that strategic missiles, they become crucial. So strategic missiles generally, they are long, typically meant for long range targets, and they are typically nuclear capable missiles. So that's why we see that all these things can be seen with with a strategic missiles. Whereas when it comes to tactical missiles, they are supposed to be used for immediate purposes in a battlefield, for example, during a battle. So these are the ones which generally will be used in battlefield. So they will be used during a battle. So they would be used during a battle. They would be short range. Generally they'll be short range because you are using it in the battlefield. So they are generally short range missiles, and that's why we see that also, that's why we see that these are likely cruise missiles because they would have higher accuracy as well. And in case of strategic missiles, we generally see that these are often uh, long range long range with a higher payload capacity or higher destructive capacity, more destructive nuclear capable missiles. Right, so this is basically what we'll see with strategic missiles, and that's why generally ballistic missiles are strategic in nature. Now when we say second strike capability, so strategic missiles are often associated with second strike capability. So second strike capability is when we have a capability to strike back after being struck. That let's say there's a country who has launched an attack on India, so then our ability to strike back is called as the second strike capability. So this is the ability to strike back, ability to strike back after being struck. All right, so this is the ability to strike back after being struck. That after somebody has attacked us, our capability to attack back is called as second strike capability, and that's why strategic missiles become very, very crucial. Because in a manner, you can also say that these are missiles which are meant more for show off. That we want everybody to know that we have these missiles. So please be aware that if you want to attack on us, we have these nuclear arsenals and nuclear missiles which we can attack back with. So that's why you just be aware. So that's why these missiles perhaps will never be used, and one should hope that they are never used. But these are missiles that become essential for a country's defense, just to show the strength of the country in its defense. And that is exactly the role that strategic missiles are playing for even India. So that's why these are different ways in which we classify the missiles, and on that basis we understand what kind of missile is used for what kind of purpose. So that's why you should know how exactly the things are, because this is where they would want to confuse you if at all they want to do something like this. So let me just go back to that article that we had seen. So this is the article that we had started with, correct? So when it comes to this article, again, this is an article about Agni Prime. So now when it comes to Agni Prime, you will have to think of certain things with regard to what exactly is this Agni Prime missile. So this basically is, you can say, a medium range, or rather an intermediate range missile. So there are all these parameters that we had seen, correct? All these parameters. So generally when it comes to these Agni missiles, you might know these are surface to surface missiles. So first thing, that this is a surface to surface missile, right? Surface to surface missile. Intermediate range missile, intermediate range missile, it is in the range of 1000 to 2000 kilometers. Then it is a ballistic missile. It is a ballistic missile, and it can be called as strategic. So that's why we see that there are all these things that we see with regard to uh, Agni Prime missiles, and that's why just remember that there are these few things that you should also always know with regard to a certain missile. And also when it comes to these kind of missiles, just think of, if let's say there is any specific function that they can do, because of which it is being launched, because of which we want to use it. So that's why just remember that all these things can actually be useful, all these pieces of information. Now, on the basis of this, the next topic for us is something called as Integrated Guided Missile Development Program. Now, this is a missile development program that was started by India back in 1983. This is for the first time that we started building missiles on our own. And as a part of this missile integrated guided missile program, there are 5 types of missiles that were produced or manufactured by India. Can you tell me which are these 5 missiles? Which are the 5 missiles which are a part of integrated guided missile development program? Any idea? Anyone who knows? Yeah, Agni is, so that's correct. What else? Prithvi, yes, Prithvi is also the correct answer. Yes, Shreya, you have completed the rest. So then you have Trishul, then there is Nag, and then there is Akash. So these are the 5 missiles. Some of you have written BrahMos. BrahMos is not a part of this. BrahMos is a joint venture between India and Russia, so not completely developed by India. So one way to remember this is Patna, the beloved city of Patna. Prithvi, Agni, Trishul, Nag, and Akash. So these are the five missiles that we started developing as a part of Integrated Guided Missile Development Program. So started this program back in 1983, and since then we started launching various versions of these five missile families. Then apart from that, there are missiles which are outside the Integrated Guided Missile Development Program as well, where the most important missile is the BrahMos missile. So BrahMos missile, there is BrahMos and there is BrahMos 2. So BrahMos missile is a missile that is a short range missile. It's a missile that has a range of 290 kilometers, and it is something that has a speed, supersonic speed of Mach 2.8. Now, Mach 2.8 being the speed of a cruise missile, because just remember that BrahMos is a supersonic cruise missile. It's a supersonic cruise missile. And that's why BrahMos, when it comes to it, becomes a very vital missile for us, because generally speaking, cruise missiles are not supersonic. Cruise missiles have way lower speed than being supersonic. BrahMos right now is the fastest cruise missile of the world. Fastest cruise missile. So that's why we have achieved something great with the BrahMos missiles, and that's why it's very, very crucial part of our arsenal. Now, with 290 kilometers and Mach 2.8, uh, initially there was a problem that we had capacity to have better range and have better speed as well. But India was not a part of MTCR. India was not a part of MTCR, that is Missile Technology Control Regime. Now, because India was not a part of MTCR, it meant that there was a limit to how fast our missiles can go and what range our missiles can take, cruise missiles can take. But then in 2016, India became a part of MTCR, that is Missile Technology Control Regime. And now we were allowed to go further than these parameters. So 2.8 Mach, meaning that 2.8 times the speed of sound. So now we were allowed to go beyond this speed of 2.8 times the speed of sound, that is Mach 2.8. And even the range can now be higher than, longer than 290 kilometers. So initially we started with BrahMos, and then we moved on to BrahMos 2, which is called as a hypersonic cruise missile with a range of 450 kilometers and speed of up to Mach 7. And that's why we are calling it as hypersonic. Anything, any speed that goes beyond Mach 5 is called as hypersonic. It is faster than supersonic speeds. So now BrahMos 2 is something like this, and more importantly, we are going to use scramjet engine in BrahMos 2. Now, scramjet engine is a very, very important engine. If you remember, in space technology, we discussed about scramjet, where we discussed that instead of carrying oxidizers, these are engines that can utilize oxygen from the atmosphere. Correct? It can use the oxygen from the atmosphere, and that's the beauty of these engines. Now, when you have scramjet engine on board any BrahMos missile, it means that it has reduced the weight of the missile. And as you reduce the weight of the missile, it will be able to carry higher loads with longer range and higher speeds. So that's why we see that scramjet becomes very, very crucial in the context of the BrahMos missile. So this is the prototype of BrahMos 2. We have to see how exactly the things go beyond this certain point. Now, beyond this, there is also a program by India which is called as Indian Ballistic Missile Development Program. Now, Indian Ballistic Missile Development Program is a program for defense, missiles that can be used for defense. So, any incoming missile, or rather incoming uh, ballistic missile or aircraft, those can be actually destroyed with the help of these kind of missiles. So, as a part of that, we see that there are two missiles being developed by India. One is Prithvi Air Defense, and the second one is Advanced Air Defense. Prithvi Air Defense and Advanced Air Defense. So Prithvi Air Defense is meant for higher altitude, called as exo-atmospheric range, and Advanced Air Defense is meant lower altitudes, that is also called as endo-atmospheric range. So this is how we see that these are so it becomes a two-tier system. One tier is Prithvi Air Defense, looking after the higher ranges, and then the second one is Endo Atmospheric Range, looking after the lower ranges. So in this manner, we have made a two-tier system. All right, we have made a two-tier system which can take care of something like this. So Indian Ballistic Missile Development Program, and we have flight tested it also, and since 2006-7 we have been testing it. All the tests have been cleared, and now these missiles are becoming a part of India's defense. Then one more small topic but important, because a lot of discussions happen around it, is radar. Now when we say radar, the meaning of radar, it becomes an acronym for radio detection and ranging. Now, radar basically will catch any incoming signal. Any incoming missile or aircraft can be detected with the help of radars. And again, there are multiple different types of radars that we have in India. Uh, just understand the basics of how radars work. So radars will work by first emitting signals. All right, they will emit signals. This antenna would send signals to the target, and these signals, they will be based largely on microwaves or radio waves. Generally speaking, we use microwaves, but we can also use radio waves. So these kind of waves, electromagnetic waves, will be used in for first sending the signals. All right, so these signals or these waves are sent by the antenna that you have here in this radar system. Now any aircraft or any missile which is in the vicinity, which is in the zone of this radar, what happens is that these waves, they will go, they will collide, and they will be reflected back. Right, so they'll go, they will go, they will collide, and they would reflect back, and they would reflect back to this antenna. So now what happens is that the target is reflected back, so we would be able to calculate the distance, we could calculate the path. How? Just very simple. You know that distance is equal to speed into time, correct? Speed we know because it is the speed of the electromagnetic waves, which is always fixed, which is always same, just like for example the speed of light. So similarly, we know that speed of all these electromagnetic waves are the same, they are fixed. So we know the speed, we know the time. How do we know the time? The time it took for this signal to go and to come back, correct? So we know the time, we know the speed, we can calculate the distance, and we can calculate this distance every second, so we can trace the movement of this uh, missile or aircraft. All right, so this is basically what we see in the context of how radars work. So it's as simple as sending signals, signals reflecting back, calculating the distance based on the time it took for the signals to reflect back. So this is how we basically use the radar. And then lastly, another technology that has been often in the news is stealth technology. Now, when it comes to stealth technology, this becomes very, very crucial, because stealth technology is something that is being used in a lot of aircrafts today. And especially when it comes to the fifth generation aircrafts that some of the countries have today, they are using this stealth technology. Now, the purpose, the goal of stealth technology is to make an airplane invisible to radar. That we want that the radar should not be able to detect any aircraft. So there are multiple things that we do. Okay, there are multiple things that are done to ensure that radars cannot catch the aircraft. So, for example, if you look at this figure, first thing that you notice is that it's black. It's very dark. It's black in color. Correct. So that's why that becomes one of the ways, because black color is something that absorbs, right? Black absorbs heat, black absorbs radiation, so it will absorb some of the waveforms as well. So first thing will be that we'll see that it will be black in color for radiation absorption. So this is one thing that they'll do. Then apart from that, what we basically see is that they make surfaces in a manner that the it's not very easy for any of the waves to reflect back easily. So you'll see that they would have sharp edges. They have sharp edges and flat surfaces. So sharp edges and flat surfaces. So they would help in making sure that any waveform that has come, it gets scattered in various different directions. So this is for scattering. This is for scattering the wavelengths or the waveforms. So this is something that we'll do. Then the material that we use, there are materials that are called as radar or radiation absorbing or absorbent material. So these kind of materials will be used to ensure that they are using stealth. Then they would use noise suppression as well. They would use noise suppression so that it is not easy to understand where it is coming from. Then special coating is also done to reduce the infrared emissions from these aircrafts. So there are all these things that will be done uh, so that we can ensure that these kind of uh, aircrafts are not caught easily. So that is what we mean by stealth technology, and this stealth technology becomes very crucial in the context of the current warfare and the ways and means of warfare today. So this is basically about some of the basics. Now again, as I told you that more than the basics that we are discussing here, the current affairs over the next 1 year will be more important for you. So that's why in this particular scenario, your uh, DRDO newsletter becomes immensely important. So please make sure that you are regular with it, that you are collecting all the information that you get from this newsletter. At least you get the topics so that you can even search for that topic, and it will take not more than, that's why I said, half an hour per month is what you need to complete holistically all the current affairs related to it. Read this question. This was asked in your 2023 prelims paper. It's a simple question, also based on some of the discussions that we have done in this chapter. Yeah, launching the poll for you. Please mark your answers. Hmm. Only 33% of you got it correct. First statement: ballistic missiles are jet propelled at subsonic speeds. What did we discuss? Ballistic missiles are immensely fast, correct? And they're not jet propelled because you just launch it and forget it. So that's why they are not jet propelled, they are not subsonic. While cruise missiles are rocket powered only in the initial phase. This is wrong. This is ballistic missile. So they have written ballistic as cruise and they have written cruise as ballistic. So this is wrong. Second statement, Agni 5 is a medium range missile. Agni 5, let's say we did not discuss about Agni 5, but it's not a medium range missile. It's an intercontinental range missile, long range missile. Supersonic cruise missile. This is not a cruise missile, this is a ballistic missile. So this is also wrong. While BrahMos is a solid fuel intercontinental, can BrahMos is what? BrahMos is cruise. Intercontinental means more than 5,000 kilometers. It is just 400 kilometers, 450 kilometers. It's not ballistic missile, it's cruise missile. Everything written in these two statements is wrong, apart from their English and grammar and punctuations. Everything is wrong. So that's why, I mean, it was an easy question. It should have been marked easily. that all these statements, look at this, I mean everything given here is wrong. They have not given a single piece of uh, correct information. Please be attentive in the class because it was an easy question to answer. Yeah. The next chapter is IT and communication, but before that, if you have any doubts, please let me know before we move on to the next chapter. Surface to surface means, the meaning of surface to surface is that the missile is starting at the surface and also going to the surface. Surface to air would mean that you are trying to strike an air target. So that will be called as surface to air. Similarly, air to surface, when you are using an airplane or helicopter to launch a missile into the surface, will be called as surface to, sorry, air to surface. So where it starts and where it ends. That is what we mean by surface to surface. What is Mach 2.8? We just discussed that it is, Mach means speed of sound. 1 Mach is speed of sound. So 2.8 Mach is 2.8 times the speed of sound. Today's PPT is not available. I'll check with the team if that's the case. Doubt section, no, doubt section is working. I'm reading out the questions from the doubt section. Please explain second type of classification. So second type of classification was what? Yeah, this is on the basis of where you start and where it ends. It's very simple that if you are starting on the surface, you say it's a surface missile. You end on the surface, so you're saying surface to surface, that the missile is going from surface to surface. The missile is going from surface to an air target. So it is air, surface to air. So depending on where it starts and where it ends, that is what it is. Strategic and tactical missiles. So strategic and tactical missiles, as we discussed, that strategic missiles are the ones which are long range missiles, heavily destructive missiles, and these are nuclear capable missiles. So these are missiles which basically are called as strategic missiles, which are important for a country strategically, and tactical missiles are the ones which will be used during a battle. When shall we complete subject? Tomorrow will be the last class. Can you discuss about Iron Dome system of Israel? So Iron Dome system basically is similar to what we discussed about the anti-ballistic missile system. Yeah. So ballistic missile defense program, it is similar to this, where they are able to intercept any incoming missile in the air itself. So that is what Iron Dome is, that they will be able to detect the missiles and strike back and destroy it in the air. So that is what this Iron Dome system is. And this kind of a system is available with only a few countries in the world. US has developed one system, Israel of course has this system, India has developed this system now. So there are only few countries. China has this system, so there China is also even developing this system. They're not completely ready with the system yet. So that's why we see that there are all these things that we see with regard to the or ballistic missile defense of India. Please mention the ranges once more. Ranges of what? Indian ballistic missile defense program in short, please. So, basically, what we are saying is that we are building a two-tier system. We are building a two-tier system. The This tier will be called as advanced air defense, and this is called as Prithvi air defense. So Prithvi air defense is for exo-atmospheric range, and advanced air defense is called as the endo-atmospheric defense, meaning that this is near the earth, this is near the earth, and this is at higher altitude. So we have made a two-tier system so that any incoming ballistic missile can be intercepted and can be destroyed in air itself instead of it. That is how we are trying to defend our territories in a manner. Ranges of short, intermediate, long, intercontinental. See, the ranges are not exactly fixed. We, for example, we would say that anything that is in the range of up to 500, 700 kilometers, we'll call them as short range missile. Anything beyond that, up to maybe 1500, 2000 kilometers, will be called as intermediate. Then comes long range missiles, which are in the range of 2000, 3000, and then beyond that you have intercontinental missiles. New inventions and experiments with respect to defense, could you get through DRDO website? I went through it, but not found anything specific. No, you go to the website. There is a part called as publications. You click on publications, then you will be taken to a lot of journals there, and then there you will see that DRDO newsletter is written. Click on DRDO newsletter. You'll get it month wise. I'm just writing it here, just that there is no confusion. So you go to DRDO website, DRDO website. On the website, you find publications. In publications, you will find newsletter. So when you click on that, you will see that you have it month-wise. It is arranged month-wise. PDFs is what you get there. Was any intercontinental ballistic missile used in any wars till now? No, we haven't used anything as such. AAD. AAD means Advanced Air Defense. That is the endo-atmospheric range of India's ballistic missile defense program. Hmm. So let's move to our next chapter, which is IT and communication. Now, IT and communication as a chapter is again a chapter which is very, very important for your prelims examination. The composition of the chapter is such that it always will be more important for prelims rather than mains examination. But it's not that questions can't come in mains. We cannot just say that questions will not come in mains. But the way this chapter is, chances are higher that you get a question in your prelims examination. And there are a lot of topics which are related to this chapter which are constantly in the news, and that's why they can actually ask a question from there very easily. They can really ask a question very easily from there. So that's why you have to be ready with all this information. Now, this chapter is also very different from many of the other chapters that we have discussed, because it's not a continuous one topic that we are going to discuss here in this chapter, but rather it, here you can say that it's a bunch of different chapters. It's a bunch of different chapters which have been clubbed together. So we'll discuss about a lot of topics. We'll discuss about the different types of electromagnetic waves, the use of electromagnetic waves, then different types of communications like what is Bluetooth, what is Wi-Fi, what is Li-Fi. Then we'll go to blockchain technology, supercomputers, quantum computers. So there are different types of topics that are clubbed together as one chapter in IT and communication. So that's why this is something which is crucial, uh, which is there for this chapter. So first thing that we'll start with is wireless communication. Now, when we say wireless communication, what does it mean? That for communicating before the between the receiver and the transmitter, there is no wire, right? There's no wire between the receiver and the transmitter. So that's why the communication is happening without the use of any wires. Now, when we need wireless communication, obviously there are different types of wireless communication. Wireless communications are based on electromagnetic waves. Now, electromagnetic, meaning that these are waves which have electrical properties and magnetic properties both, correct? They have electrical properties and they have magnetic properties, and that's why they are being called as electromagnetic waves. Now, when it comes to these electromagnetic waves, they become very crucial. And just understand why only electromagnetic waves, why not different waves or other waves? For example, why can't we use sound waves, for example? Why do we want to use electromagnetic waves? Why do we not want to use sound waves for any kind of communication? So this is where you have to understand that how wireless communication has to work. So there are two important reasons why. So if I ask why electromagnetic waves for wireless communication, so there are two reasons for it. Two reasons for it. One reason is that we want to have speeds which are fast. So they have very fast speed. They have very fast speed compared to any other wave. They can travel at the speed of light, that is 3 into 10 to the power of 8 meters per second. So that is one reason. Second, they don't need they don't need any medium. They don't need any medium to travel. They don't need any medium to travel. So that is basically what we mean by electromagnetic. That is why we are saying that electromagnetic waves are important for wireless communication. Why these are the ones being used? For example, let's say sound waves. Sound waves compared to these electromagnetic waves, first, are very slow. Second, they always need a medium to travel. So they can only travel when you have air, water, or some kind of solid they can propagate in. But when it comes to electromagnetic waves, they can propagate, they can travel even in vacuum, where there is no medium between the sun and the earth, for example. There is no medium. But all the magnetic waves are reaching. You see the auroras, so all the magnetic waves are reaching. The light waves already are obviously are reaching, because of which the entire earth is lit up. Infrared rays are reaching, ultraviolet rays are reaching, and all these electromagnetic waves are coming from the sun to the earth in vacuum, without any medium being present there. So that is the importance of electromagnetic waves, and that's why for wireless communication we are making the use of electromagnetic waves and not any other wave. Now, in this context, two concepts of wavelength and frequency, they become important. And very often in this entire chapter, we'll keep talking about these two terms, wavelength and frequency. So let's start with the understanding of what do we even mean by wavelength and frequency. So wavelength, as you can see, distance between two consecutive peaks of a wave or troughs of a wave, or any two similar points on a wave, will be called as the wavelength. And it is because it's length, so that's why it is measured in meters or maybe fractions of meters, like millimeters, micrometers, nanometers, and so on. So this is what wavelength is. So if you see this, so this is how we look at wavelength. So as you can see, distance between two similar points will be called as wavelength. So I can start at any point. For example, let's say I can start here, so then completing one whole round. So starting from here, going all the way down, let's say going all the way up, and coming to an exact same point. So this will be called as what? This will be called as wavelength. So that's why the distance between two consecutive peaks or troughs, or two consecutive or two similar points in any wave, is called as its wavelength. Now, if you look at the two figures, let's say if we label these two figures as A and B, then in case of A, you see that the waves are, you can say, very close to each other, right? They are not taking a lot of space, whereas the waves that you see in the second diagram is where they are taking up a lot of space, right? They are taking up a lot of space. So that's the basic difference between these two waves. So the first one, that's why it's called as a short wave, and second one is called as a long wave. So long wave or short wave depends on the distance between two consecutive or two similar points on any given waveform. Now the second concept is of frequency. Second concept is of frequency. So frequency is the number of waves that form in a given length of time, and usually measured as number of wave cycles per second, or hertz. So hertz is this, hertz is the unit of using these waves. Uh, uh, Hertz is basically the unit of frequency. So what do we mean by frequency? We are saying how many waves can pass through in a given second will be called as the frequency. So for example, let's say I mark this as 1 second. Suppose that this point to this point, all right, let's say this point to this point, this is 1 second. Suppose that this is 1 second. Suppose that this is 1 second. Now, if I ask you, can you tell me how many waves are passing through in the first picture? How many waves are passing through in 1 second in the first picture, and how many waves in the second picture? Can you tell me this? Yes, Satyapal, you are correct. Others, please answer. Yeah, Nilanjana correct. Ankita correct. Aditya, no, your answer is not correct. Arumita correct. Bhanu correct. Gautika correct. Yeah, correct. So, how many waves? Count this. One. Here to here it is one. Here to here it is the second wave, and here to here it is the third wave. So there are a total of three waves in this. How many in this one? You are starting here and you are ending at a similar point here. So there is only one wave here. Correct? So how many waves are passing through in a 1 second in the first wave? Three. In the second wavelength, just second wave, just one. So that means that more number of waves can pass through in 1 second. So that's why it has high frequency. And here less number of waves can pass through in 1 second. That's why it has lower frequency. So that's why you can see that frequency and wavelength, they are inversely proportional. So when you have short wave, you have high frequency. When you have long wave, you have low frequency. Correct? So short wave, high frequency; long wave, low frequency. So this is how it is. Correct? This is how it is. And that's why uh, this is basically how we are looking at these two waves. Now, overall, when it comes to these two waves, so that's why these two concepts become important. But related to these two is another concept, and that is the concept of energy, and how energy is also related to these two. So, if you look at this diagram, this is the complete spectrum of all the electromagnetic waves. So, we start with the shortest wavelength, where you have gamma rays, X rays, ultraviolet, then comes visible light, then infrared, then microwaves, and then lastly radio waves. So radio waves have the longest wavelength. Radio waves have the longest wavelength, and uh, the gamma rays have the shortest wavelength. So as you can see that when you have long wave, you have low frequency. When you have short wave, you have high frequency. But even energy is a concept which is related to this. So, for example, about gamma rays we discussed. If you remember nuclear discussion that we had done in nuclear technology, we discussed about gamma rays, that gamma rays are responsible for the one of the reasons of the high energy that you get in nuclear fission. Correct? So gamma rays have extremely high energy, very high energy. And compared to that, radio waves have very low energy. Mobile phones are using radio waves. So just imagine if mobile phones were not using radio waves, but rather they were using gamma rays. What would happen then? We would not survive. The gamma rays would completely destroy our cells and tissues. So we wouldn't survive if gamma rays were being used in mobile phone communication instead of radio waves, which are fairly safe. So that's why understand the relation between the two. Long wavelength, long wavelength means low frequency, and it also means low energy. And that's why when you have short wavelength means high frequency and also high energy. So that's why for any wireless communication, we would prefer radio waves. We would prefer the longer wavelengths rather than the shorter ones, because longer wavelengths would have lower energy, and that's why it's easier to use them. They have lower energy, so it's easier to use them, safer to use them. And that's why you'll see that in most of the cases, radio waves are used for mobile phone communication. For rather many of the other uh, radio, when many of the other wireless communication also, you'll find that we actually are making the use of radio waves. So that's why radio waves are important. So radio waves, now for every wave that we are discussing about, there are three parameters that become important and you should remember them. Their wavelength, their frequency, although still I believe that frequency is not as important a parameter as wavelength is. So wavelength, frequency, and their applications. Where are they useful? So these three things you should know, because they can, if they want to, they can make a question out of things like this. So radio waves, they have a frequency of up to 30 gigahertz and wavelength greater than about 10 millimeters. All right. So, and that's why they actually are used for communication. Now understand why they are being used for communication. Why are they being used for communication? Two important reasons. One, they have long wavelength. They have long wavelength. Now, how is it relevant? Having long wavelength, how does it make a difference? Why can't we use a short wave for mobile phone communication? Because long wavelength means that they can travel longer distance, longer distance without losing energy. So they can use their energy efficiently. But in case of short wave, what happens is that short waves can travel shorter distance. They do not travel very long distance. They travel shorter distance. So that's why you have to use a lot of energy. So for example, if I had to go from this point to, let's say, this point, so then suppose that if 30 joules of energy was being used by radio waves, then for the same distance, higher amount of energy will be used for gamma rays, maybe 200 joules, very high amount of energy. So it's not energy efficient, even if, let's say, it was not harmful for us. Suppose that gamma rays were not harmful, they wouldn't do anything in our body, they wouldn't cause any cellular damage, they would not burn through your tissues and cells. Yet we wouldn't want to use gamma rays because their energy efficiency will be very low, because they emit a lot of energy. They don't conserve their energy, they emit a lot of energy, and that's why for longer distances they are not useful. Now, radio waves, just imagine that we are getting information from our communication satellites, which are placed at 35,786 kilometers. So, almost 36,000 kilometers. So, we are able to get that signal from there, right? We are able to get that signal from there, and we do not face any problem in that. So, that is why we see that longer wavelength are useful. And then, second is that they have low energy. They have low energy. So how is it important to have low energy? Low energy would mean that they are less harmful, much less harmful. much less harmful, and that's why they are safer. So because otherwise high energy would mean that it can destroy the cells and tissues, as is the case with gamma rays, even X rays. You will see that so much protection is provided across X rays, so that uh, people can be safe. So that's why we see that there are these two parameters which make radio waves the most important when it comes to the use in communication. Then after that we have microwaves. So microwaves, they are in the range of 3 to up to 33 gigahertz to 30 terahertz, and wavelength range is 10 millimeters to up to 100 micrometers. Now microwaves can be used in radar. We just discussed that they can be used in radar. Then apart from that, they can be used in high bandwidth communication, meaning that high frequency communication is where they can be used. Because wherever, let's say, radio waves cannot be used or radio signals are jammed and all these things have happened, this is where microwaves can be useful. And they can also be used as a heat source. They are also associated with heat, and that's why in microwave ovens also they are being used. And if you remember, we also even discussed something called as cosmic microwave background. So there also we discussed that because of the immense amount of heat that was present in the early universe, that's the heat that is able to manifest itself as microwaves. So that's why microwaves are always associated with heat wherever, in whatever form you have heat. Then infrared. So infrared is between 30 terahertz to about 400 terahertz, and wavelength from 100 micrometers to up to 740 nanometers. Now, obviously, they are invisible to our eyes, but they can be used. For example, there are night vision cameras or infrared cameras. So they can be useful in infrared cameras. So now, in case of infrared cameras, many times, for example, in wildlife sanctuaries, national parks, etc., there are camera traps at night. At night, there are camera traps where we are trying to trap the movement or track the movement of animals at night. So there, obviously, in the forest, there is no source of electricity. Sorry, no source of light, etc. So normal photographs can't be taken, right? Normal photographs cannot be taken because it's uh, completely dark, and that's why cameras cannot work. So infrared works there. And why infrared? Because infrared is something also associated with heat. It is also associated with heat. So any heat source, even if, let's say, you just go on a run, if you go to run and you start sweating, you start feeling warm or hot, is mainly because of infrared rays also will be emitted from these cases. So that's why even the sun will also emit infrared. So wherever you have a heat source, big or small, even if you light a matchstick, it will emit infrared. So the movements of animals also means that infrared are actually being emitted, and that is what we can capture. So that's why in all these cases they can be useful. Then we have the visible light, the ones that we understand, the ones that our eyes can perceive. So you can see is between 400 to 800 terahertz, and wavelength of about 740 nanometers to 380 nanometers. So this is the range of the visible light. And visible light, perhaps for us, is the most important. We wouldn't be able to see the world if not for the visible light. It's also used in communication, something that we'll discuss a little later, how exactly it can be used in communication, but it can be used in communication. But beyond this, so for communication, for communication, we can use radio waves, we can use infrared, we can use microwaves, or we can use the visible light. Others can't be used. Others meaning ultraviolet, X-rays, and gamma rays. These three cannot be used. These three cannot be used for any form of communication. So we have ultraviolet. So ultraviolet is in the range of 8 into 10 to the power of 14 to 3 into 10 to the power of 16 hertz, and wavelength between 380 nanometers to up to 10 nanometers. So that is the range of ultraviolet. Now, in case of ultraviolet, ultraviolet light can also be harmful for us, right? They can be harmful for us. Now, in this particular scenario, let's also try to understand why and which are the ones that can be harmful. There are three different types of ultraviolet light: ultraviolet light A, B, and C. UVA, UVB, and UVC. So these are the three types of ultraviolet rays. So UVC is the shortest one, and that's why it has a wavelength of 100 to 280 nanometers. So because it's the shortest means highest energy. Highest energy means the most damaging as well. So that's why they are the most dangerous, most harmful for our body. They're the most harmful for our body. So that's why just remember this, that these are the shortest wavelength, and these basically are the most harmful of the UV radiations. Now, UVC is absorbed completely by the ozone layer. This is very, very crucial, because although they are the most dangerous for us, they are completely absorbed by the ozone layer. And ozone layer, which is there in our atmosphere, the ultraviolet C, which is coming from the sun, will be completely absorbed there. And that's why we need not be concerned about UVC. But there are man-made sources. For example, in welding or in mercury lamps, we see that ultraviolet can be, or germicidal lighting. In all these cases, ultraviolet C can be present. Even in filters, for example, for filtration, ultraviolet C can be used. So, for example, if you see water filters and their advertisements, they'll say RO plus UV plus UF plus XYZ technology, mineralizer, and whatnot. So, in that case, when we say when they say UV, uh, RO plus UV, UV means ultraviolet. Why ultraviolet? Because ultraviolet can kill the life forms. RO system, reverse osmosis, cannot kill a bacteria. Alright, it cannot kill a bacteria, but ultraviolet can. So that's why ultraviolet is also used in many of the cases, so that the biological uh, toxins can be removed, they can be killed. So that is why UV will be used. So, and even that's why we also try to save ourselves or protect ourselves from this. So for example, welding torches, wherever welding is happening, you'll see that there is a shield that uh, the people who are doing welding, they will be carrying. That sheet will be made of a metal, so that it saves them against ultraviolet. So ultraviolet C rather. Then there is UVB. So UVB is between 280 to 315 nanometers, and this is something that can cause sunburn. Now, it's not that it is completely reaching the surface of the earth, only about 5% is able to get through the ozone layer. So, ozone layer will absorb 95%, 95% of all these rays, ultraviolet B rays, but 5% will still not be filtered out, and they will reach the surface of the earth, and they can harm the top layer of the skin. They can harm the top layer of the skin, they can cause sunburns, etc. They also lead to aging of the skin over time, if let's say somebody is uh, exposed to UVB a lot. And then lastly, we have UVA. So UVA is something that starts between 315 and goes up to 380 nanometers. Now it's very easily able to penetrate through the ozone layer. 95% of it is able to reach the surface of the earth, and this is something, it can cause skin aging, it can cause spots and wrinkles, and they can reach deep into the skin layers. They can reach deep into the skin layer. So prolonged exposure of the sun can lead to these kind of issues, and in some cases they have even been linked to cancer. They have been linked to skin cancer. So UVA can become a reason if very prolonged for many years somebody is exposed and not using any kind of screen, sunscreen, etc. Then in that case it can be dangerous. Then after this, we have X-rays. So X-rays are in the range of 3 into 10 to the power of 16 to about 10 to the power of 18 hertz, and wavelength between 10 nanometers to up to 100 picometers. So this is the range of X-rays. This is the range of X-rays. Now, in case of X-rays, what we see is that there are two types of X-rays called as soft and hard X-rays. So this, what we see is for soft X-rays. This is the range for soft X-rays. Whereas for hard X-rays, they have the wavelength and frequency same as gamma rays. So this is what we'll see. So for example, if you see this, gamma rays, they have frequency is greater than 10 to the power of 18 hertz and wavelength less than 100 picometers, and they can be very dangerous. They have very extreme amount of energy. They can damage the tissues, they can cause burning of the tissues and cells, they can cause cancer. So there are different things that can happen, and that's why gamma rays are very, very dangerous. They are extremely dangerous, and it's not that we don't use it. We use it in limited way, in a manner that targeted way it can be used with, but ultimately we try to avoid any kind of contact with gamma rays. So these are the different types of electromagnetic radiations with their wavelength, frequency, and their uses. So any question if you have from whatever we have discussed until now, anything that you want to ask before we move on to the next topic? X-ray slides. This is the X-ray slide. Frequency of UV rays, I omitted that information from here because that will be irrelevant information. So that's why I did not use that information here. It would be unnecessary information. What impact radio waves can do to us? So see, impact of radio waves is not well established. There are some research papers here and there which say that radio waves can be harmful, but by and large we understand that radio waves do not cause harm uh, in the moderate amounts that we are consuming them. Is frequency of all the rays compulsory to learn? I would say not. I would say that wavelength parameters and applications, they are more important. Uh, in the past papers also we have seen that they have focused more on wavelength rather than the frequency. But sometimes you never know, because some of these waves, especially uh, radio waves, visible light, these become important because they are used a lot in a lot of cases. So that's why I've said that this we should know. I opened DRDO website, but publication isn't opening. It should open. I even used. I opened it today. I mean, I took that picture even today in the morning. It should work. Please explain slowly. I'm actually going very slow. Because these are factual information. There is nothing to explain for me. So that's why everything is written here only instead of me writing everything. These are very factual areas. The areas which are not factual, this is where I'll take a lot more time to write and explain everything. Radar, I did not understand. So radar, just understand this, that when it comes to a radar will first, what does radar do? It detects anything that is in the surrounding. So for example, if there is an aircraft that is coming from outside the Indian borders, or any missile that is coming, it can detect them. How does it detect it? By releasing certain waves, by releasing radio waves or microwaves, and those microwaves will go, they will collide with the airplane and they will come back. And that is what we calculate, how much time did it take. So we know the time, we know the speed of electromagnetic waves, so that's why we can calculate the distance, we can calculate where exactly this incoming aircraft or missile is located. That is what radar do. radars do. Any metal protects us from UV rays if ozone layer is not present. Yeah, metals in general, or any kind of coverage in general. Even if you are wearing full sleeves clothes and etc., they would be able to save you mostly from these ultraviolets. Use of x-rays, two ways, either in medical usage. You might know that when, for example, if there is somebody suspected of any fracture or break in the bones, x-rays are done, x-ray images are taken out. So in medical field it has applications, in industries also it has a lot of applications. Use of gamma rays, go back to the chapter nuclear energy, that was about gamma rays. Nuclear fission is where gamma rays are emitted. We discussed about important radioactive elements and how exactly they make the use of radiations. We discussed about uh, radioactivity, there we discussed about gamma rays. So we know that it can be used in industries, it can be used in agriculture, it can be used in nuclear fission. There are different ways, and all of that we have discussed in the chapter of nuclear technology. Can waves be linked to satellites? Yeah, of course. Satellite communication is happening with the help of radio waves. How are they communicating from almost 36,000 kilometers? With the help of radio waves. Can we get break? Yeah, we'll after this questionnaire, I'll take a break, and then on the other side, we'll have the rest of the discussion. I'm not able to download monthly magazines from website. I'll check that, or if there is any problem, I'll check with the website team. Can you drop an email to me about this so that I don't forget it? Class till 7 or 8. There are certain topics that I want to finish today. So not up to 8, maybe 7, 7:15, 7:30. Somewhere around that time is when we will end the class. So it will not be a 4 hour class, it will be a 3.5-ish hours class. Okay, so many of you have asked about tomorrow, and some of you also have said that tomorrow it's completely impossible for you to take the class. See, there are two things that we can do, either tomorrow or the next Saturday. These are the two options that we have, because Monday onwards, I don't know what the next subject is, but Monday onwards, the next subject starts. So I have time tomorrow, or I have time, I can take next Saturday. So now that depends on you. So we'll discuss that later about how exactly we can go about the class, when we can take the class. So let's take a break. It's 5:30. So let's be back by 5:40. Let's be back by 5:40 and continue with our discussion. Right. Welcome back, everyone. So now we have discussed about the electromagnetic waves, and now we see how electromagnetic waves are being used in all these various forms of wireless communication. The first wireless communication, a very, very important one, perhaps something that a lot of us have been using, and this is Bluetooth. Now, in case of Bluetooth, what we see is that this is a short range communication, of course, correct? It doesn't go very long distance. The range is generally less than 10 meters, less than 10 meters of range. So it means that how much? I mean, you can say just like one room or little more than a room. So that is what the range of Bluetooth is. The frequency at which it operates is 2.4 gigahertz. Now, what we are saying is that it uses ultra high frequency radio waves. Ultra high frequency. Ultra high frequency means what? Shorter wave, right? Higher frequency, shorter wave. So, shorter wave means less range, correct? Shorter wave, less range. As we discussed about something like a gamma radiation, that you cannot use it for long distance at all. I mean, you cannot use it for communication at all, but it will dissipate a lot of energy very quickly. So that's why ultra high frequency means that it has lesser wavelength, and less wavelength means it has less energy. So that is basically what we see with wireless communication, that is Bluetooth. Now, in this particular scenario, so Bluetooth, one thing that you should know about Bluetooth is that it works on frequency hopping spread spectrum. Frequency hopping spread spectrum. Now, when it comes to frequency hopping spread spectrum, this is a kind of technology that is which adds to the security on it, which adds to the security of this Bluetooth communication. It helps in adding to the security or making Bluetooth more secure with spread spectrum frequency hopping. So makes it difficult to detect. This is a safety feature, or rather a security feature. Makes Bluetooth difficult to detect. So that's basically what we see about wireless communication based on Bluetooth. Then after that, there is something called as NFC, or near field communication. Now, near field communication has an operating frequency of 13.56 megahertz and has a range of less than 10 centimeters. Less than 10 centimeters, meaning it's this small, or in most of the cases it is generally just 2 or 3 centimeters, not more than that. So it will be, I mean, the devices have literally have to be this close to each other, then only communication can be established in them. In case of Bluetooth, that was not the case. Bluetooth, we said 10 meters, right? 10 meters, meaning that entire room or even beyond the room, it can travel through the walls as well. So that's why between two rooms also you can communicate with Bluetooth. You might have tried it and you know how it works. So that's why even if there are two different rooms, you can still communicate with the help of Bluetooth. But with NFC, all that is very difficult because you need the devices to be very, very close to each other, and then only you can establish communication between the two. Where exactly do we use it? ID cards, many of the ID cards, if you have used Metro, the Metro cards where you just go and touch the Metro card and it lets you go, in these kind of biometric devices, which are there in offices, schools, colleges, etc. So all these are what? All these are NFC based scenarios. So NFC can be used in this particular scenario. So that's why, as you can see here, for ticketing, identification, attendance, physical access, in all these cases, we actually can make the use of NFC. Read this question. This was asked in your prelims examination. It's an easy question. Please mark your answers. So 60% of you have marked C, which is the correct answer. Let me discuss this with you. With reference to near field communication technology, which of the following statements is or are correct? First, it is a contactless communication. This is fine because it is wireless, so that's a contactless communication that uses electromagnetic radio fields. This is also correct. We are making the use of radio waves here, so this is perfectly fine. Second, NFC is designed for use by devices which can be at a distance of even a meter. This is wrong. We discussed that maximum of 10 centimeters. Even a meter is this much, correct? So that's why 1 meter, no, maximum 10 centimeters, and that too, in most of the cases, as we discussed, just 2 to 3 centimeters. That's it. So 2 definitely is wrong. And you get the answer from here. So 1 and 2 cannot be correct. 1, 2, and 3 cannot be correct. 1 already is correct, so only 3 cannot be correct. So correct answer is 1 and 3. So third is NFC can use encryption while sending sensitive information. This is correct, especially in terms of payments. In terms of payments that we make in cashless payments that we are making, in this case we can actually make the use of NFC. So that's why the correct answer will be only 1 and 3. Then we have a very important mode of wireless communication, and this is RFID. Now, in case of RFID, what we see is that RFID is where it is called as radio frequency identification. So, obviously, again, we are using radio waves only here, but this time the use, you can say, the way it is used is very similar to what we discussed about NFC. All right, it's very similar to how NFC works, but with certain advantages. The advantages, for example, the range. Range is up to 100 meters. Then no line of sight required, meaning that it can pass through obstructions. Pass through obstructions like wall, etc. So even if there is a wall, just like Bluetooth, even if there is a wall, it can pass through the wall as well, and it can communicate between the two rooms, or even if there are different obstructions, obstructions will do nothing. Now, here what we see is that when it comes to RFID, RFID makes the communication very fast. All right, it makes the communication very fast. Now, how does it make it fast? It makes it fast because you can communicate with number of devices at the same time, or number of objects at the same time, number of readers at the same time. So typically an RFID system works like this. If you see here that you have an RFID reader, and then RFID reader, and there is an RFID tag, and the reader is connected to a database. Reader is connected to a database, so through an antenna it will gather the information from the tag, and it will pass on that information to the database, and that is where the information will be checked, and ultimately you get the result. So RFID will be used in this sense. RFID will be used in this particular way. So there is a very famous example, very common example here in India right now where RFID is being used. Can you name it? Where is India using RFID? Yes, Akhil, you are correct. Ravi, correct. Faris, correct. Shreya, correct. Yahya, correct. I was talking about FASTag. FASTag in the toll plazas, wherever the payments are automatically being taken from your vehicles. So that fast tag system is basically using RFID. So that's why RFID can make that work very seamless. Similarly, in warehouses, you can use it, in shops, you can use it, in libraries, it can be used, where the scanning of all the products can be done at one time. Instead of RFID, if NFC was used, then you'll have to go to each and every product and do the scanning because the range would be just 2 3 centimeters, correct? But in this case, you can just stand at one place and the entire area can be scanned if it is 100 meters or nearby. So that's why it is very very crucial, and it makes the communication very very fast. Then there is Wi-Fi. Now in case of Wi-Fi stands for wireless fidelity, operating frequency of 2.4 or 5.2 gigahertz. Now, when it comes to Wi-Fi, has been one of the very, very important technologies. I'm sure many of you are using Wi-Fi, if not all of you. At least many of you have used or are using Wi-Fi even now, probably during the lecture. So, Wi-Fi does what? It helps you connect to the internet, correct? Now, in this context, when it comes to Wi-Fi, we have seen that the technology has evolved over time, starting from 802.11a, B, G, N, AC, now AX. So initially, the Wi-Fi system could connect to one system wirelessly with very low speed, all those things. But then we saw the improvements. And then we saw that instead of one device, a couple of devices could be connected. The speeds started to improve, and then it started to gather momentum. It started to become famous, and start when it started to become famous and popular. This is when Wi-Fi 802.11n was renamed as Wi-Fi 4, because now it was being used by people, common people here and there. So that's why there was a change in name that was done, so that it becomes easier for people to use it. And subsequently, this was named as Wi-Fi 3, Wi-Fi 2, and Wi-Fi 1. And then after that arrived Wi-Fi 5. And right now, you can say the world is largely using Wi-Fi 5. Most of us largely are using Wi-Fi 5, where very easily you can connect to 5 to 7 devices, and you get decent speeds while getting connected. So we see that there are all these improvements that have happened. The next phase of development is Wi-Fi 6. The next phase of Wi-Fi 6 development is Wi-Fi 6, and Wi-Fi 6 has already arrived. It's not that it's in the future, it has already arrived. In India, also, there are certain service providers who are providing Wi-Fi 6. Uh, Recently, this happened, I mean, just a couple of months back, and that's why I thought that it will be very good for me in the class. So, whether, I don't know whether you can see this. Do you see this? That on the Wi-Fi signal, there is a small 6 written on the top. I don't know whether on your small screens it is visible or not. It is visible? Yeah. So that small 6 that you see, it signifies Wi-Fi 6, because Wi-Fi 6 is available. So I was randomly somewhere where I was connected to the Wi-Fi, and suddenly I saw that 6 and I took a screenshot, because I knew that this is something that will be useful for me in the classroom. Not all the service providers have started providing Wi-Fi 6 in India, but there are some who have started providing Wi-Fi 6 in India also. Now, with Wi-Fi 6, we get a lot of advantages, and let's try to delve upon that. That what are these advantages of Wi-Fi 6? There are two key technological features in Wi-Fi 6. One called as OFDMA, and the second one is called as MUMIMO. OFDMA stands for orthogonal orthogonal frequency division. Orthogonal frequency division, multiple access. This is OFDMA, and MUMIMO stands for multiple user multi input multi output. All right. So multiple user, multi input, multi output is called as MUMIMO. Now these two systems, or these two, you can say, technologies, they are the key features of Wi-Fi 6. They are the ones leading to all the advancements in Wi-Fi 6. Now what advancements? What are these advancements? Most importantly, it is much faster. It's much faster. It has lesser latency. We'll discuss about latency. It has better security. It has improved battery life, and it can connect to much more number of devices. Can be connected to can be connected to more number of devices, more than 30 devices. More than 30 devices are can be connected. So just imagine that Wi-Fi 5 effectively can connect to 5 to 7 devices. After that, it starts losing its speed. But Wi-Fi 6 can connect to 30 or more devices without losing any speed. So very fast, lesser latency. What is latency? Latency is something that we also call as lag in the network. This is nothing but the lag in the network. Now, what do we mean by this lag in the network? Many a times you might have seen this, that if you are connected to a certain system, maybe audio and video are not synchronized. That maybe the lip sync is happening first and then the audio is coming, or maybe the audio is coming first and then the lip sync is happening. Something is off. So you might have observed this, correct? In many of the videos, I don't know whether it is happening during the lecture also. Sometimes it is possible that it might happen during the lecture also. So that basically is latency. That is because of latency, lag in the network. Because what happens is that there is a certain speed at which the waves have to be transmitted. But for some reason or the other, one wave is traveling faster than the other. So that's why audio wave, let's say, is traveling faster, then audio reaches first and then the video. So that lag in the network can happen due to n number of reasons. Either your internet connection is not good enough, or my internet connection is not good enough, or maybe your device is not responding properly, or maybe my device is not transmitting properly. So there are many reasons. There are different types of reasons that can lead to a lag in the network, and that lag is what causes this latency. Even if you see many of the news channels where they are talking to somebody on the ground, you'll see that whatever is being spoken from the ground, there is a lag, and the news room is receiving that information 2 seconds, 3 seconds later. So that also happens because of lag in the network. So that lag is called as latency, and it can very easily happen that, let's say, there are many systems which are connected to only one single device. That is something that can cause latency. And the speeds can cause latency, the device performance can cause latency. So there are a number of things that can cause latency. Now in this context, what we see is that this latency can be drastically reduced with the help of Wi-Fi 6. There is another latency. If you have uh, anyone who recognizes where this screenshot is from. Yes, it is BGMI, Battleground Mobile India, formerly PUBG, not PUBG anymore in India. It is BGMI in India now. Correct. So, for for those of you who have played, I hope that you don't play anymore. You are in a in a preparation mode. I sincerely hope that you don't play anymore. If that was the past, let it be your past. You might see that there is a number that is published here, and this is for those of you who have played. So there is a number here. So if it is visible here, it is written 24 ms. So it means millisecond. So when this number is small, 20s, 30s, 40s, 60, then in that case, your performance will be good. I mean, your device performance and your gaming performance will be good. If that number goes to 200, 300, etc., then you will see that you are not performing as good as you would want, or your system is lagging behind, your player is lagging behind, and it uh, gives you, you can say, you can uh, it gives you very bad performance, right? And you would not feel nice about how the game is going. And that's why, that is where you would say that, okay, I'm not performing well because the lag in the network is very high, my ping rate is very high. So because my ping is high, that's why I did not perform. Otherwise I would have performed very well. Just I'm not able to play well because of the system. I'm not, yeah, the word that Ravi you have written, I'm not a noob. It's just my system which is not letting me perform. Correct. So that also is the lag. So 24 ms means 24 milliseconds. That there is a lag of 24 milliseconds between your system versus the server system. So that kind of lag can be drastically reduced with the help of Wi-Fi 6. So that's why there are all these advantages of Wi-Fi 6. And all these advantages, these are based on two important technologies. One is OFDMA and the second one is MU-MIMO. Understand what's happening in these two technologies. First, OFDMA, this reduces latency and increases efficiency. Reduces latency and increases efficiency. How does it do that? Understand this. Now when you are interacting with the system, when let's say internet is working, there are packets of data that are transmitted. All right, packets of data that are exchanged in the network. So for example, let's say there are three systems. Suppose that there are three people who are connected to any Wi-Fi system. Let's say I have my laptop on which I am working. Then let's say my brother is also my brother has maybe his phone and he's watching a video on that phone. And I have somebody else in my home who is playing a video game, let's say on the mobile device itself. So there are three different devices which are interacting, and there are three different types of data that we are using, or three different types of ways in which we are working. So what happens is that, generally speaking, a packet of data, when it is getting transmitted, it will be transmitted like this, and not the entire set of data is being used. So for example, maybe only this much of it is being used, or maybe only this much of it is being used, or maybe only this much of it being used. So it could be something like this, that one, let's say, is about video, then the second one is somebody, let's say, listening to music, so it could be audio, and the third one perhaps is working, so maybe it is text. So there are three different types of data exchanges that are happening, and every data is basically, as you can see, that every data package is not completely utilized. This is what changes in OFDMA. In OFDMA, what happens is that one single packet of data will be able to carry all the three. It will be able to carry all the different types of data, all the data from these three different devices together. So this is what happens in OFDMA. And that's why we are saying that it increases efficiency. That's why we are saying that this is increasing the efficiency, because now it is able to utilize the entire packet. So now what happened? Efficiency increased. It's just like, for example, let's say we suppose that you are talking about any e-commerce company. Suppose that you have Amazon. So Amazon would have its warehouses. So let's say, instead of one truck being loaded with all that it can and then going to the city, instead of that, warehouse was loading one package in one truck and sending it, second package in second truck and sending it, third package in third truck and sending it. It is highly inefficient if they did that. So they would not do it. Correct. What they'll do is that they'll carry as much as they can, and then it will be sent to towards the city or towards the final delivery. So that increases the efficiency. So that is what OFDMA does. And when it comes to MU-MIMO system, it is something that increases the capacity. MIMO system would increase the capacity, and that's why you get higher speeds per user. You get higher speed per user. Now, what exactly are we saying? We are saying that these fully loaded trucks, these are going according to according to an area. So, for example, let's say three different areas in one particular city. So in that one city, they have to carry everything to three different areas. So for example, area A will have one truck. So everything of area A in one truck, everything of area B in second truck, thing of area C in third truck. Otherwise, let's say there was only one truck that was roaming around, then it will take a lot of time. Suppose that there was a package to be delivered from Delhi to Chennai, right? And although there are different packages to be delivered, one in Mumbai, one in Kolkata, one in Bengaluru, one in Hyderabad, and then one in Chennai. Suppose this is the scenario, and there is only one truck. It goes from Delhi to Mumbai, Mumbai to Bengaluru, Bengaluru to Chennai, Chennai to Hyderabad, Hyderabad to Kolkata. Then it would take a lot of time. Instead of that, let's say we are loading one truck with everything Mumbai, one truck everything Bengaluru, one truck everything Chennai, one truck everything Hyderabad, one truck everything Kolkata. You increase the speed of delivery would increase. So one is increasing the efficiency and the other one is increasing the speed. So that's why these two technologies, they become very very crucial, because they make the entire thing more efficient and faster, both at the same time. Read this question. This also has been asked in your prelims paper. I'm launching the poll for you. Please mark your answers. Hmm. So I see a lot of confusion. 37% A, 12% B, 20% C, and 32% D. Let me clear this for you. What is the difference between Bluetooth and Wi-Fi devices? First is Bluetooth uses 2.4 gigahertz. This is correct. We discussed this. Wi-Fi uses 2.4 or 5, which is exactly 5.2, but it's fine. So this is correct. Second is Bluetooth is used for wireless local area network only, whereas Wi-Fi is used for wireless wide area networks only. Now there are two onlys. First, you have to be very cautious when you see these extreme words. Now, what do we mean by local area network? So there, when it comes to networks, there are different types of networks. We have personal area networks, PAN. We have local area networks. We have wide area networks, and we have metropolitan area networks. So it depends on the coverage. How much coverage is there? So personal area network means that this is a small area, like a room. All right, it's just like a room. So inside the room, now can you use Bluetooth? Can you not use Bluetooth inside the room? You can. So you can use it for personal area network, not only for local area network. So that's why that first part of the sentence is wrong, because you can use it in personal area network. Local area network means, like, let's say a building. Suppose that we are talking about a building. So then in that case, local area network. Now Wi-Fi is useful in this. Wi-Fi can work in personal area network and local area network also. Then there is wide area network. It's more like a locality, you can say. It's more like a locality. So then in that case, it's way wider. And then metropolitan area network covers probably the entire city or a large part of it. So this is how we define. So that's why this is wrong, because Bluetooth can be used in personal area network, whereas Wi-Fi can be used in local area network and personal area network both. So that's why second is wrong. So if second is wrong, fourth automatically is wrong. Third is when information is transmitted between two devices using Bluetooth technology, Devices have to be in the line of sight. Do they have to be in line of sight of each other? They don't. We just discussed that even within a room, or across the room, rather across the room also, you can use Bluetooth. As long as the range is up to 10 meters, you can do that. Have you not tried it? You can use it. So that's why this is wrong, that they don't have to be in line of sight of each other. Wi-Fi technology used need not be in the line of sight. This is correct, but first part of the sentence is wrong. So that's the correct answer will be A. Then we have Li-Fi. Now, in case of Li-Fi, Li-Fi stands for light fidelity. All right, it stands for light fidelity. So light fidelity meaning that we are going to use light as the mode of transmission, right? Light is being used, so we are communicating via light. So that's why transmits data via light. It's 100 times faster than Wi-Fi. Speed can go up to 224 gigabits per second. And because it runs on light waves, the wavelength used is 300 to 800, 780 nanometers. Now, these are approximate figures. Remember that sometimes 780 can be 800, 775, 750, 380 can be 400, 375. So this much of variation will be there. uh, Signals cannot pass through light. Now, this is very, very important, that here no line of sight. No line of sight communication. All right, no line of sight communication. Obviously, because light cannot pass through walls. If you have a tube light or an LED bulb in one room, does it also light up the next room? It doesn't, unless you're, I mean, if it is transparent and windows and doors are open, then only, otherwise not. It cannot pass through walls. So that's why no line of sight. So that's why communication also cannot pass through walls. And it is way more secure than Wi-Fi. So that's why Li-Fi. Now, Li-Fi is useful wherever we are trying to avoid other modes of communication, where we are trying to avoid radio waves, where we are trying to avoid microwaves. So when we are trying to avoid all these different electromagnetic rays, then only Li-Fi becomes useful. For example, let's say inside an airplane. Now, when you are in an airplane, you would be asked what? That you should be in flight mode, correct? Your mobile phones will be in flight or airplane mode. So, what does it mean by being in flight or airplane mode? That radio signals are being cut off, apart from maybe something like a Bluetooth, etc. But wavelengths, otherwise, radio wavelengths are being cut off, so that it helps in the pilots having a proper communication, so that it does not disturb the communication of the pilots. So that's why you would be asked to put your phones, etc., on flight or airplane mode. So when you are in the airplane mode, this is where Li-Fi is useful, because Li-Fi uses what? Light waves. The pilots are not communicating with light waves, they are using radio signals to communicate with the earth. So then Li-Fi can be very easily used without any kind of interference. So that is where, to wherever we want to avoid the use of radio waves or other electromagnetic rays, this is where Li-Fi can be useful. So useful when other electromagnetic waves can't be used for wireless communication. And because visible light is being used here, transmits data via light, that's why it is also called as visible light communication. It is also called as visible light communication. Visible light communication. So that is what we mean by Li-Fi. That is what Li-Fi is. Now, interestingly, there are two questions that have been asked on Li-Fi in past 5 to 7 years? Just read these questions. Very easy question. Oh, have I committed some mistake in writing something? Let me go back to it after the class. Sorry, after this poll, after this question. Good. So 76% of you have marked C. This is the correct answer. With reference to Li-Fi recently in the news, which of the following statements is or are correct? First, it uses light as the medium. Light as the medium, this is correct, for high-speed data transmission. Now, look closely. There are two parts to this sentence. One, that light is being used as the medium, and second is that you are doing high-speed data transmission with it. So that's why this is a correct statement. Second, it is a wireless technology. This is also correct, and is several times faster than Wi-Fi. This is also correct, that it is several times faster than Wi-Fi. So this is also correct. So correct answer will be C. That is both 1 and 2. What mistake? Oh, it's sorry. This is line of sight communication. That is what it means. By mistake, I've written no line of sight communication. Please make this correction. This is line of sight communication. Yeah. Read this question. This was asked in your 2020 paper. Please mark your answers. There's one statement which is very, very easy, and that helps you in marking this answer. So 49% you have marked C, and actually C is the correct answer. But I see a lot of A's. Let me just discuss this. With reference to visible light communication technology, which of the following statements are correct? First is VLC uses electromagnetic spectrum wavelengths 375 to 780 nanometers. This is correct, more or less the range that we discussed. So one is correct. Second is VLC is known as long range optical wireless communication. No, we discussed that you can only communicate within a room. Within a room, it cannot pass through walls. How can you have a long range communication with it? You can't. It's a very short range communication because it can only communicate within a room. It cannot pass through walls at all. So how can you establish a long range communication? You cannot do that. So that's why 2 is definitely wrong. So you have 2 here, here, and here. So anyway, A, B, and D are gone. Third statement is VLC can transmit large amounts of data faster than Bluetooth. This is perfectly fine because it is faster than Wi-Fi. Wi-Fi anyway is faster than Bluetooth. So obviously Wi-Fi is going to be way faster than Bluetooth. So 3 definitely is correct. Now there is a problem with statement number 4, and I get it why a lot of you marked A. Maybe because of statement 4. So statement 4 says VLC has no electromagnetic interference. Electromagnetic interference with what? They should have completed this sentence. Interference with radio communication. Radio communication, mobile communication. They should have written this. This should have been written completely. Then this is a correct statement. Otherwise, when you look at this statement independently, that VLC has no electromagnetic interference, that would be wrong. Why? Let's say there is, hypothetically, there is another Li-Fi source that inside the airplane, so when other electromagnetic can't be used for wireless communication, so that's why what we do is Li-Fi is used to avoid, remember this, avoid electromagnetic interference. And how are we avoiding interference? How are we avoiding interference? By using two different wavelengths. Light rays have different waves, radio waves have different waves, so they cannot interfere with each other. But let's say when you independently say that it has no electromagnetic interference, let's say inside an airplane there are two Li-Fi sources, then there are chances that they can interfere because they have the same wavelengths. So they can interfere then. So that's why saying strictly that they have no interference would be wrong. That's why I'm saying that it's a half sentence. I don't know why these kind of vague sentences have been given. And this also 2020 paper, the other question that we discussed in terms of nanotechnology, even that was a 2020 paper. In 2020 and even in 2019, these two have been papers where a lot of vague questions have been asked, where anyone can go. And I mean, I would love to sit with the panel and ask them, why did you give these questions, first of all, and secondly, can you explain me how exactly do you think that this is a perfectly fine statement? It is not. But in the absence, you can say that it's, even if it's not the correct answer, it is, you can say, the most appropriate option. There is no other option which is as appropriate as C. So then I would mark C. Otherwise, strictly speaking, I would say that the fourth statement is not completely correct statement. Either they should have extended it to write with radio or mobile phone communication, or they should have written that it can avoid. The real thing would be the most important. The actual sentence should have been that they are used to avoid electromagnetic interference. So that whenever we want to avoid electromagnetic interference, this is where you can make the use of VLC, or you can use Li-Fi. But unfortunately, they've not done that. So any questions if you have from whatever we have discussed in the last 45 odd minutes? Any questions here? All good? No questions? That's wonderful. I cannot say that Li-Fi and VLC is same. See, Li-Fi is a form of VLC. VLC is visible light communication, and one of the ways in which VLC can be used is Li-Fi. So Li-Fi can be said to be a form of visible light communication. Li-Fi technologies are not hijackable like traditional Wi-Fi. Absolutely correct. Very, very difficult to break through it. Li-Fi and Wi-Fi related topic questions asked in mains also, they haven't been asked, and it's unlikely that a question like this can be asked in your mains. These are areas from where we expect questions to come more in your prelims examination. What is low bandwidth and high bandwidth applications? Low bandwidth means, you can say, low frequency. All right, low frequency, and high bandwidth rather means higher frequency. Li-Fi can be used to connect with the internet. Yes, absolutely, it can be. Next subject will be, I'm not sure, I'm confused because I think it's either polity or it's environment. One of these two subjects is the next subject for you. Turning lights on, an entire house will be bathed with by security and seamlessly fast internet. Yeah, I mean, hypothetically, yes. With Wi-Fi, absolutely. What type of Wi-Fi we can use and how I know about this? See, generally speaking, most of us are using Wi-Fi 5. And if you want to know what Wi-Fi you are using, you just ask for the URL of whoever your network provider is. They will give you an IP address. You type that IP address in your, let's say, address bar, and then you will be taken to a page. You go to the settings, and there you will find what all they are connected to. So, for example, I had checked this for my internet connection, and I saw that they are providing me connection for Wi-Fi 3 also, 4 also, and 5 also. So all three connections they are actually providing for. So you can see that if you want. Why do they have to hijack a Wi-Fi? I mean, if they want to breach your security, if they want to get to your internet, they want to get to your device, that is one of the ways that they can do it. Low bandwidth means high frequency. No, 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 no. It's opposite. It's opposite. High, when we say high bandwidth, the meaning of high bandwidth is that higher amount of frequency is available. It's just like this. That when you say higher bandwidth, it means that you have a broader spectrum of frequency available. This is high bandwidth, right? This is high bandwidth. So higher range of frequencies available. And this would be lower bandwidth. So lower range of frequencies available. Are ping and speed the same? No. Ping rate basically determines time, the lag in time. So it's more factor of a time, and speed is more factor of the internet speed. That in terms of Mbps, Gbps, whatever it is. So that is speed, and ping rate is more of the time. That time lag of 10 seconds or 10 milliseconds or 2 microseconds and so on. Will you take environment? No, no, I'll not be taking environment. Somebody else will be taking it. Can you give a 5 minute break? Let's study for some more time before taking a break. A very, very important topic actually, and this is evolution of mobile networks, where we are going to discuss about 5G networks. Uh, Two or three of you are writing about break. Do you really need a break, or shall we continue? Can you give examples of low bandwidth? Yeah, we'll discuss this. I mean, low and high bandwidth in this topic of 5G itself. We'll discuss this. So most of you are saying to continue. So I'll go along with the principles of democracy and I'll continue. So yeah, so evolution of mobile networks. Now here we are largely going to talk about 5G networks. But before we understand 5G, when we say 5G, what is the meaning of 5G? 5G means what? Fifth generation, right? This is what 5G is. 5G means fifth generation. So fifth generation meaning that this is the fifth generation of mobile networks that has now arrived. So means that there have been four generations before that. So what are these four generations? The first generation introduced in 1980s, speed of just 2.4 kbps going up to 14.4 kbps and supports voice only. Supports voice only, meaning what? You can only talk on the phone. We can only talk on the phone. This is what it means by being voice only. And then in second generation, we have speeds going up to 50 kbps, and now it supports voice and data. Meaning what? That you can talk and use internet. So you can talk on the phone and you can also use the internet. This is what it means by voice and data support. So now we had voice and data support both. So this is basically where we are with second generation. But the internet speed was very low. I mean, I don't know whether you have had the opportunity to use second generation mobile phone network, but if you have had this opportunity, you know what kind of privilege it was to use that internet. The slowness of the internet, forget about videos were not even a thing with 2G networks. uh, Even loading an image would take so much time that if you want to, let's say if you are doing an image search, you do that image search on Google, go have your lunch, come back, and by that time you come back, you'll see that the results would have loaded. So it was very slow, but yet it was internet on the phone, which is itself was a privilege. As I told you, it was a privilege for us to even imagine that this was even possible. But before that, we used to have dial-up internet on the computers, which were slow but connected to the phones wire with wires, etc. And now on the mobile phone we can use the internet. So that was unthinkable for a lot of people, and that's why having that internet, which was very very slow, I mean, you cannot even compare, and you cannot even gauge compared to the kinds of internets that we are used to in today's world. When you say slow internet, you do not know what slowness of internet meant 15 years back. You probably will throw away your phone, break your phone, or break somebody's head while using that internet if you get that internet to use today. So that, but still, it was a privilege, as I said, that at least internet was there on the mobile phone. Now this also changes with 3G or third generation. Speed goes up to 3.1 mbps, which is a great speed to have, that now at least you can watch videos. You can use faster internet, and of course supports both voice and data. Sorry. Then comes the fourth generation. Now with fourth generation, we see that the speed goes up to 100 mbps. So not only uh, audio, video, etc., live streaming becomes possible. The kind of internet that you are using, perhaps, maybe some of you are connected to your mobile phone network and not a Wi-Fi kind of network. So in that case, you are using a very fast internet because you are able to live stream a video like this. So now that all was made possible by 4G with the immense speed that it came with, and of course supports both voice and data. But then uh, this is where we see another very very important change, and that was the change between two technologies, one called as LTE and the other one called as VoLTE. LTE and VoLTE. LTE stands for long term evolution. This stands for long term evolution. All right. So on one hand, you have long-term evolution, and this one, voltage, stands for voice over long-term evolution, voice over LTE. Now, what changed here? Until 3G, or until you can say 4G LTE, you could either talk on the phone or use the internet. You couldn't do both at the same time. All right, you couldn't do both at the same time. You'd either be able to use the internet or you'd be able to uh, talk on the phone. And if you are talking on the phone, internet will be disconnected. When you disconnect the phone, then only internet resumes. This was up to 4G LTE. So in 2G this was the case, in 3G this was the case, up to 4G LTE this was the case. And then comes VoLTE in the second half of 4G. And this is where it introduces VoLTE, and VoLTE means that now you can talk on the phone and use the internet both at the same time. That you could now be talking on the phone while scrolling your Instagram. So that's why both actually could be done at the same time. So that is what it means by VoLTE. So VoLTE basically is use of using voice and internet at the same time. At the same time. So that is basically what it meant by being in VoLTE. This is what exactly VoLTE is. But in case of LTE, what we see is that LTE is not going to give you this kind of luxury that you could talk on the phone and you can use the internet both at the same time. So that basically has been the difference. Now, basically comes 5G. Just give me one moment, please. Yeah. So now comes 5G. Now with 5G, the things change. How exactly do the things change now? The speeds are drastically improved now. The speeds can go up to 10 Gbps. 10 Gbps, of course, supports both voice and data. Of course, it is all VoLTE, right? It is all VoLTE now. So that's why there are all these things. And when we look at the advantages of 5G technology, we understand that there are a lot of things that they can do. So obviously, they also use radio waves. Now, today we see that it is estimated that it will have space for more than 7 trillion devices at the same time. 7 trillion devices. And it would obviously offer much better speeds. And for India, it is estimated that the numbers would reach up to 88 million connections by 2025. And that's why we see that slowly and steadily the penetration of 5G networks in India has also been increasing. So, in this context, when we look at 5G, there are certain features of 5G that we should understand. So, let's try to understand what 5G is and the various aspects and features of 5G. Now, 5G obviously will be very, very important for you in the examination because it has been introduced now in the country. The penetration is increasing. So, coming year's exam, I mean, I would say both your prelims and mains examination. If the questions come in prelims, fine. If they don't, in the mains examination. And if they don't come in 2024, it will remain an important topic in 2025. Now, so how 3G and 4G works, they are pretty similar. I mean, how they work are very similar. 2G, 3G, 4G, they all work very similarly. 5G is a bit different in its approach, in the way it provides you the connections. Now, how they are different, also let's try to understand that how exactly they are different. You might have seen mobile phone towers here and there. Have you seen mobile phone towers? Sometimes uh, building rooftops here and there, you might see that there are mobile phone towers. So these mobile phone towers, they will be installed every 500-meter radius or every 1 kilometer radius and so on. This is how they are connected. Now, in this context of mobile phone networks, 2G, 3G, or 4G, in 5G, it is different. That apart from the bigger mobile phone towers that you have something called as the small cell towers as well. Why? What's the reason? The reason is that here we are also using higher frequencies. High frequency means what? Lower wavelength. High frequency also means higher energy use. That means that it will not travel very long distance. Shorter waves are being used. So shorter wave means shorter distance. So these kind of towers, they help in providing that connection in a smaller area, faster connection in a smaller area. So that's why number of these small cell towers have to be increased. You have to increase the density of these small cell towers. So something like this will happen. Let's say you are talking about a neighborhood where you have all these houses. All right. And then let's say that there is intersection of roads that are running. Right. Suppose that intersection of roads are running like this. Now what happens in this case is, suppose that, or let me increase the complexity of the road network. So let's say we are talking about road networks like this. All right. So let's say road networks like this is what we have. So in this context, suppose that you have a small cell tower here. Let's say there is a small cell tower here. So this tower will cover this area very well, this area very well, this area very well, this area very well, but it will not cover these areas well. All right, it will not cover these areas well. So that's why we'll have to have another mobile phone small tower, let's say here, so that it provides network here, 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 this side like this. So what then happens is that it is covering the areas. So if this white one was covering this much of area, if the white one was covering this much of area, the blue one is covering this much of area. So in this manner, what's happening is that they are able to cover their areas well, right? They are able to cover their areas well. So this type of density of network will have to be increased. This is something that will have to do. So these small cell towers, they provide the faster speed. They make sure that the speeds increase, but at the same time they do not have good ranges. They do not have good ranges, so you cannot just have one cell tower every kilometer and be done with it. You'll have to increase the density of the mobile phone towers, and this is one of the problems also with the infrastructure development of 5G, because then it's going to take a lot more time for us to implement 5G everywhere in India. It's not going to be easy. So there are all these features. So first feature basically is higher frequency band. So here you can see that you are using both the sides. You are using lower frequency and you are using higher frequency. You are using both, correct? You're using higher frequency and lower frequency. So that's why we have millimeter wave frequencies which provide transfer faster transfer, and that's why these have shorter range. They have shorter range than the and so that's why this is basically here we see that they have uh, higher bandwidth, so more energy, so faster but shorter range. And that's why they are easily blocked by obstacles. So that's why there are a large number of small cell towers that are placed in close proximity of each other. So that's why this is how we are making sure that it doesn't hinder anything. Then we are using MIMO system. So MIMO, as we discussed, multiple input, multiple output. This is where it is able to improve the signal strength and reduces interference. So there are multiple inputs and outputs which are available at the same time. So this is something, as we had discussed earlier also, this also helps in increasing the speed per user. It increases the speed per user. Then there is something called as network slicing. Now, network slicing is basically the division of network into various applications. So that again, there is no interference between who is using what. So if you see this picture, for example, so what it is suggesting is that for Internet of Things devices, you should have different set of frequencies. Then for automotive purposes, different set of frequencies. For smartphones, different set of frequencies. This is called as network slicing. So what then happens is that we are easily able to avoid any interference and congestion in the network as well. That you have three different roads which are going to three different directions instead of one single road going in all the directions. Then in that case, the congestion in the traffic will be more. So we are avoiding the congestion in the traffic by doing this. So this avoids traffic congestion in the internet connection. So that is basically what we do in case of network slicing. Then it also uses the features of edge computing. The features of edge computing. Now, edge computing is able to reduce latency and it improves the application performance. Now, understand what is edge computing. Now, normally what happens is that let's say you have a central server and there are a lot of devices that are connected to this server. Now, when that happens, what happens? We discussed this in discussion of latency. When number of devices, a lot of devices are connected together in a server, then in that case, it can bring in latency in this network. So instead of that, what we would want is that there is a central server, and this central server is connected to a bunch of devices. All right, it is connected to a bunch of devices, and the end user is connected to these devices. The end user is connected to these devices. So then what happens is that the congestion is less, correct? Congestion is less and it will reduce the latency altogether, because now very easily you are only interacting with your local server. So for example, let's say instead of you going to the manufacturing unit to buy something, you go to a grocery store and buy the same thing, correct? So that makes your job easier. You are just going to the shop that is near your home instead of going to the factory from where it was being manufactured. That makes your job easy. So that is what edge computing is. So this is basically what edge computing is. All right. So this is how we see that edge computing becomes very, very crucial, because then it is closer to the user and makes it easier for the user to interact with the system. Then there is a system called as OFDM, which is similar to, you can say, OFDMA more or less. So it improves the efficiency and the reliability of the wireless communication, and this is something also which helps in reducing latency. So this also helps in reducing latency. Then overall, we know that because of all these things that we have added, it has lesser latency. So a latency can be as low as just 1 millisecond. So latency is very, very low when it comes to this particular scenario of 5G. And then there is network densification. So what we discussed, that they would be using a large number of small cells. So involves placing more cells in a given area to improve the capacity of the network. So that's why, so we are talking about a large number of small cells, large number of small cells to provide the 5G network. So that basically is what we see in this particular scenario of network densification. So that's why there are all these features, and all these features, they add up and they provide all the required advantages. Now in the context of India, there is something else which is called as 5GI. Now 5GI is more or less, you can say, standing for 5G for India, something that will be useful in India, something that the government of India wants to implement. Now, when we are looking at this implementation, when we are looking at this implementation, this is where we are trying to ensure that we can increase uh, the penetration of 5G in India without having to use a lot of small cells, because small cells is what creates the infrastructure related problems, and it is something that can create a lot of issues for the network, and getting the network to the required positions in time. Otherwise it will take a lot of time. So what we are trying is that we are trying to use the existing 3G and 4G cell towers for 5G implementation without having to use a lot of small cell towers. So this is where we have seen that students also coming from colleges like IIT Madras and others, they have come together and they actually had suggested this to the government of India, and the government of India also has been working on this. So this is something that will ensure that there can be interoperability with the existing networks, and it can help in localization of 5G. It will help in getting 5G connections to the entire country quicker than normal 5G. So that is how we see that 5G I is supposed to work. So faster data speed up to 10 Gbps, ultra low latency, just 1 millisecond, Internet of Things, tele-education, agriculture, manufacturing, telemedicine, traffic management, increasing the GDP and digitization of economy. Everywhere we see that 5G becomes advantageous, and 5G can be very, very crucial in implementing of all this, in implementing of all these different types of networks. So that's why in this particular scenario, 5G becomes essentially crucial. And but there are certain issues that remain, that investment requirements are high because you have to lay down new infrastructure, correct? We have to lay down new infrastructure. So that's why it increases the investment. Then after that, it becomes expensive. The spectrum is expensive because it's just like buying a bigger piece of land. That if you go and buy a house, smaller house will cost less in the same area. Smaller house will cost less and bigger house will cost more. So it is simply similar because here you are using broader, higher bandwidths. So that's why you will see that it will be more expensive. Then also the issue of compatibility with older devices. The devices that have started coming after 2020, etc., they are more compatible with 5G than the earlier devices. So that also is one of the challenges. Then lack of uniform regulatory policy, that every country is governing 5G with their own regulatory policies. So it's not that they have a uniform regulatory policy according to which all these things are being governed. So that also becomes a challenge. And then high battery drain of the equipment which is using 5G, because the bandwidth requirements are high, energy requirements are high, so obviously the battery usage is also high. So there are all these issues that we have currently with 5G. We would want better penetration, we would want better speeds. That on paper it is 10 Gbps, but if I ask you, anyone who is using 5G, that are you actually getting 10 Gbps speed even if you are connected to 5G? The answer perhaps is no. So that's why there are all these issues that we have currently with 5G networks. Read this question. It has been asked in your paper. Please mark your answers. So 50% of you have marked correct answers. 22% of you have marked A, which is wrong. With reference to communication technologies, which what is or are the difference or differences between LTE and VoLTE? First is LTE is commonly marketed as 3G and VoLTE as advanced 3G. Wrong. It was introduced only in 4G. Go back to the discussion that we did. Where has it been introduced? 4G. 3G does not have the concept only of VoLTE. So that's why there is no chance of saying that it is 3G and advanced 3G. This is wrong. Second statement says it is data only technology and VoLTE is voice only. No, it is not voice only. Voice over LTE, meaning that both internet and voice can be used at the same time. So it can't be voice only. It is making you use internet while talking, and it's not data only. You are talking with LTE also. Correct answer, that's why, is D. Neither one nor two. It's a very simple question again, but I see a common problem with these kind of questions. Wherever the answer is neither one nor two, or when all the statements are wrong, this is such a common mistake that I see with so many students, that I mean, this is not with you, but how human brain works, that you feel that at least one of the answers should be correct, at least one of the statements should be correct. Why would they give us two completely wrong statements? Either both should be correct or at least one should be correct. And this is how our brain starts functioning without objectively looking at what's there in front of us. And every class I go to, when I see that there is an answer which is saying that all the statements above are wrong, all the two, three, four statements, whatever they are, every statement is wrong, I see that there is a lot of hesitancy in marking those kind of answers. And that, I don't know whether it is the case or not, but I see that as a common practice all across. And whenever I've given any even practice question also in the class, I've seen this happen. So start working in a different manner. I know being optimistic and being positive is good, but not in a manner which brings you wrong answers. Hmm. Now, one more topic we'll do today, that is Internet of Things, and then we'll close today's class, because after that, the topics that we have are longer topics. So, this is Internet of Things. Now, before we even begin what is Internet of Things, let me start with a question. Take 2 minutes if you want, read this question, and in the comments, please let me know when you have completed reading the question. Hmm. So you have done. Okay, as an experiment, I'm launching the poll. I want to see who will mark a wrong answer here. Let me see who marks wrong answers. Can I get 100% correct answers in this? Only 60% of you thought that answer should be B, and rest of you thought that answer shouldn't be B. We are reading the topic of Internet of Things. Why would I give you a question based on anything else? The answer, of course, is Internet of Things. I know I've not taught you Internet of Things yet. This is a test. We say na, that sometimes you have to take an intelligent guess. If you are hanging at 40s and 50s, you should take an internet. You should take an intelligent guess. So the question, I mean, we are discussing Internet of Things. So the answer has to be Internet of Things. That's why I told you just read this question, because this question is self-explanatory, and it explains you Internet of Things, that how Internet of Things works. That when an alarm of your smartphone rings in the morning, you wake up and tap it to stop the alarm, which causes your geyser to be switched on automatically. The smart mirror on your bathroom shows the day's weather and also indicates the level of water in your overhead tank. After you take some groceries from your refrigerator for making breakfast, it recognizes the shortage of stock in it and places an order for the supply of fresh grocery items. When you step out of your home and lock the door, all the lights, fans, geysers, and AC machines get switched off automatically. On your way to office, your car warns you about traffic congestion ahead and suggests an alternative route. And if you are late for a meeting, it sends a message to your office accordingly. So this is a luxurious posh life that probably many of you think should you should be leading. I don't. Uh, and this is what Internet of Things is. Understood what is Internet of Things? It's just connection of various devices that can interact with each other. Understood? You get the topic? Yes? So no need for me to explain any further, but I'll still do it. So Internet of Things, a concept that was coined by Kevin Ashton back in 1999. Now this is where we are talking about a bunch of digital devices, appliances, vehicles, etc., and almost all possible gadgets under the sun connected and exchanging information with each other to make our lives easier. So where all these devices can interact with each other, right? They can interact with each other, and hence they can make your life easier. So this is basically how we look at Internet of Things. Now today Internet of Things can be used in various ways. When it came out as a concept, it was still as a concept it existed, but it couldn't be useful as it is today. Because today you we discussed about Wi-Fi 6, that we have moved towards Wi-Fi 6, where so many devices can be connected together with a very fast speed. Now we have 5G in mobile phone networks as well, which also automatically makes the speed much faster as compared to the previous generations. So now with the advent of all these, with artificial intelligence also being there, now Internet of Things is going to take its place. Now it is going to become the thing it was always supposed to be. And it's not only about a luxurious posh life that we want to live perhaps, but it's a lot of different areas of application, a lot of different sectors where Internet of Things is essentially useful. So for example, smart city projects, traffic management, infrastructure management, movement of, or let's say even optimizing electricity in the entire city. Internet of Things can do that for us. Health monitoring, smart grids, retails, hospitality, factories, fitness tracker, even in agriculture. In all these cases, we see that smart home is the question that you had asked in your UPSC paper. So there are a number of areas where Internet of Things can actually become useful. And that's why it can be easily uh, seen to be useful in a lot of different ways. And today, that's why we see that in India, we are trying to develop an industry, or we are trying to develop this entire sector altogether. So, for example, an industry worth $15 billion is what India is now trying to set up, granting 18 crore rupees in the initial stage to promote research and development in the area. Then for MSME sector, for the small and micro enterprises, up to 6 lakh per enterprise per annum will be given if they are working with something that utilizes Internet of Things. Then after that, what we have seen is that in a lot of curriculums it has started coming in the academia it has started coming in. Then it also will be used as a, it will be made a part of Digital India mission, and so that it can get more focus from the side of the government. Then the National Digital Communications Policy, that also has started using, has included Internet of Things on in the policy itself. And lastly, 2018, we saw that it was the first time that an airport in Sikkim, that is near Gantok, was opened, which has an IoT based system integrated there, and which is basically an early warning system. It's like an early warning system against seismic activities or against earthquakes. So that's why it can provide an early warning against earthquakes. So this kind of a system has been set up in Sikkim. So that's why we see that there are all these steps that we have started taking in India, and that's why we believe that this will help in growth in the future. But ultimately, there are certain issues also that we have with it. So, for example, the initial setup cost is high. The electronic devices that we need, the kind of connections that we need, all this will need a lot of cost, a lot of financing. So that's why setup cost is high. Then internet connectivity and security issues are there. It can lead to a lot of jobs because this ultimately is going to lead to a lot of automations. It will lead to a lot of automations. So that would mean that a lot of people are going to lose their jobs. Then concerns of digital surveillance as well. Reliability of sensors is also one of the factors, because if all these devices have to interact with each other, their sensors have to be wonderful, correct? The sensors have to be very good, so that they are without any lag, without any problems, they are able to interact with one another. Then consumption of power can be high because there are so many electronic devices that will be connected in the system. Then there is a lack of international standardization, which also can create a lot of compatibility issues. Suppose that there are 5 different devices that you are using, and there's one device that has been designed in India. There's another device that has been designed in US, one from China, one from South Korea. So that means that they might be having different standards, they might have different policies, and that's why all these devices together in one system may not even be able to interact properly. So that also can be one issue. And then lack of skilled resources to maintain and run such kind of systems. So because it's a new technology, it's a growing technology, you do not really have a lot of engineers or academicians or people who are skilled with Internet of Things. So there are all these factors, and that's why we see that there are all these limitations right now when it comes to Internet of Things, right? So any questions if you have from here? I'll not start blockchain today, we'll discuss about blockchain and everything tomorrow. So blockchain, supercomputers, quantum computers, these are the 3 topics which are left in this chapter. And then after that, the next chapter for us will be IPR, that is intellectual property rights. So if you have any questions, please let me know now. Network slicing. See, network slicing means what? That you are cutting something into slices. So this is what we are doing here, that if we have a bigger bandwidth, one part of bandwidth is being given for one kind of application. So for example, let's say one part of bandwidth only for mobile communication, one part of bandwidth only for Internet of Things devices, one part of bandwidth only for something related to, let's say, satellite communication. Just giving an example. So when you are doing this division, you are slicing the network, that only this part of network will be used by this application, this part of network will be used by that application. Reliability of sensors in IoT means. So reliability of sensors, meaning that sensor means what? If you remember in robotics, we had discussed about sensors. That sensors will get the information from the environment, right? From the nearby areas, correct? So then that information will be sent to the central processing unit, the controller. So here also that has to happen, that because there are five six devices we discussed about, the geyser and the locking system, the electricity system, all these they have to interact with one another. So if they have to interact, their sensors have to be good so that they can understand what is their role when they have to do something. If the sensors are not reliable, they are not able to pick up information from the other devices, then it is futile, then IoT system breaks. So that is what we mean by reliability of sensors. Is there any class tomorrow? Yes, we will have a class tomorrow. I'll complete the rest leftover portions in tomorrow's class. 5G is offering us seamless internet connectivity with certain advantages like greater bandwidth, low latency, and network slicing, etc. Yes, that's absolutely correct. Distribution of internet, I'm not sure what you mean. Science and technology webinar I'll be taking on Monday. It will be scheduled for Monday evening. Class timing tomorrow. Can we not start at 4 o'clock tomorrow also, so that even if I need to stretch a little, I'll have that time? If possible, take class on next Saturday. I have college exam on Monday. See, I don't mind. I have no problems with it. I think again I'll have to make a democracy here. Tell me if you want. I just want to know from you, and depending on that, I can do the class. Sunday, that is tomorrow, or do you want next Saturday? When do you want the classes to happen? I'm launching the poll. Let me try to understand what you want. Please mark A or B. Science and technology webinar will be at the same time, usual time, 8:30 p.m. So majority of you want classes tomorrow. So 64% of you have said that you want class tomorrow. See, even if yeah, Vishant, you had written this. Even if you have a class on Monday, you can listen to the recordings of the class after your exams are over. And if you have any doubts, you always have my email ID. You directly get in contact with me if you have any problem, any doubts, anything that you don't understand. I know that these extra classes are also happening because the problems that I have had, and because of which I have not been able to take classes regularly. Otherwise, we probably would have finished yesterday itself. Please do something about annotations. Please provide us geography annotations are also not available. I'll check this. I'll again check this because even yesterday I spoke to them and I was told that they have been uploaded. But I'll again just go and cross check everything. When the internet is being hijacked, why internet of things are necessary? See, I mean, when somebody wants to get to your device, internet can be a way to get into your device, and they can break the security of your device if they want something from you. If you are that important that your phone has that kind of crucial information, confidential information, somebody can try that. Leaderboard, I'll show the leaderboard. So Faris, Vishant, Ravi, three people I would say have scored well. I mean, I know because of the last question. I mean, this last poll I should not have started before the leaderboard scores, because that might have influenced something, and one or two wrong answers you might have gotten because of that. But ignore that, and yet I see that there are so many of you who have given perfectly correct answers. 7 out of 7 correct is wonderful for every one of you who have done it. Congratulations, and for the rest of you, I hope that you understand how the things went wrong. I'll tell you something frankly. I commanded Gemini AI to table 50 questions. It exactly did as what we are studying, and every topic as per science and technology. Yeah, of course. I mean, Gemini is wonderful, and I still believe that OpenAI is better than Gemini. I've used both, and I see that I feel that I get more accurate results and better results with OpenAI, that is ChatGPT, rather than Gemini. I don't know what your experiences have been. Yeah, the class is done for today. I'm just looking at the doubts. There are no new topics to be started today. For current affairs, Byju's monthly magazine sufficient. See, I keep telling this all the time that one should always try that you should read from a daily current affairs source, meaning the daily Hindu analysis that we do in the morning, or the text based articles that we get as CNA. Either that. If not, the at least weekly, you should try that you are uh, going according to the current affairs requirements. And also, monthly is the last resort, that if you're not able to read a lot because of college, before of because of your job or whatever be the reason, then I understand that you are referring to monthly magazines. I'm not talking about monthly magazines of Byju's only. Go to any institute. I would never want you to go through a source like that. That I know that a lot of you perhaps are also uh, big fans of PT65, 365, etc. I would never prefer that. I would never prefer it over a daily current affairs, because that, I mean, that takes away the detailing of current affairs. That topics might be same. Understand the difference. One can say that, look, everything that I had given in this one small compilation, questions came from there. But could you actually solve the question from there? Answer more often than not will be no. Topics will match, questions wouldn't. Questions will only match when you are actually giving it more time, when you're going into the basics of that and that topic, and you're trying to understand that topic. That's very, very crucial, and that's why I often keep saying that at least ensure that on a weekly basis, at least I'm saying, best case scenario daily, but at least weekly you should keep on ensuring that your current affairs is up to date. So please do that. Tomorrow's class will be at 4. We'll start at 4 so that any extra time that I need, I can take that extra time. Are these topics important for even 2027? Yes, of course they are. I mean, all the static areas that I'm discussing, apart from some of the newspaper clips that I discuss, apart from that, everything else will remain important as long as the technology remains the same. Kurukshetra PIB website address, please. So, I mean, PIB is pib.gov.in. Kurukshetra, because Yojana and Kurukshetra both actually are, uh, they belong to the publication division of Government of India. You can just search it on Google, you'll get it directly. I face problem in current affairs, language problem. What should I do? Try to understand, maybe let's say if it's an English problem, then also try to sit with maybe word meanings on internet searches so that it simplifies things for you. Or you can ask the faculties of respective subjects, or maybe the mentors can help you in understanding that. So that in one way or the other, try to simplify them. If let's say English or words are becoming the problem, then maybe you can keep on searching on for the words so that you can understand the meanings. I found DRDO newsletter, but how to use. So just look for any new technology that has been tested. So any new missile, any new aircraft, or any new artillery, anything new in the weaponry that India has. Just look for that. Where can I find Byju's weekly current affairs? There are two webinars that happen on Tuesdays and Thursdays. We are conducting webinars for you. So that is the weekly source. So a couple of you have written that you face mentorship problems. If you face those problems, you directly write an email to me also. All right. Whenever you face that problem, some for some reason you were not able to connect, write an email to me. I will ensure that you get mentorship. Any such problem that one part of the service or another, if you're not uh, getting the proper responses that you needed, you please send a copy of that email to me also. I, on my behalf, I'll talk to these teams and I'll try to ensure that you get what you want. So let's end the class here today. We'll start with blockchain in blockchain technology tomorrow. So blockchain, supercomputers, and quantum computers. These three are the important topics left in this chapter that we'll take up tomorrow. Thank you.